Look up. That ceiling is stone. It rises nearly 50 meters, yet there is no steel frame hiding above it. So what holds it there? Medieval builders did not solve this with one miracle invention. They built a chain of forces: arch, rib, pier, and buttress. The Gothic style emerged around Paris in the middle of the 12th century. Builders wanted greater height, wider space, and more light. Earlier stone churches relied on round arches and thick load-bearing walls. Stone roofs pushed outward, so windows stayed small and masonry stayed heavy. A pointed arch changed the geometry. It could span openings of different widths and usually pushed less sideways than a round arch. Next came stone ribs. Two pointed arches crossed over each bay, making a skeleton. Thin, flat stone, called webbing, then filled the spaces between. Have you ever tried balancing building blocks into an arch before the last piece arrives? Without support, they fall. Carpenters solved that with wooden centering beneath the stone. Limestone arrived by cart or boat. Masons shaped each wedge, lifted it by rope and pulley, then closed the rib at the crown. Only then could centering come down. The ribs gathered the ceiling's weight at a few precise points. Clustered piers carried those loads downward, instead of asking the whole wall to bear them. But the vault still shoved outward. What stopped the wall leaning away? A flying buttress, a curved stone arm outside, caught the thrust and carried it across the aisle. Each stone flyer had to meet the wall where the vault pushed hardest, then land on a heavy outer pier rooted in the ground. With ribs, piers, and buttresses sharing the work, walls could open into vast windows. After the fire of 1194, Chartres was rebuilt over 26 years. At Beauvais, the choir vault climbed to about 48 meters, roughly a 16-story building. How far could builders push before the system pushed back? Now picture one outer support cracking as townspeople gather below. That moment is reconstructed. But in 1284, part of Beauvais' newly completed choir vault really collapsed. No surviving account names one failed buttress, and the exact mechanism is still debated. The broken stone itself gave the builders their hardest lesson. They could not make the old bay stand by hope. They cleared the ruin, studied where the loads had escaped, and redrew the structure. First, make the bays narrower. Extra piers divided the broad spans, so each vault section and each support had less territory to control. Then double the outside support. The repaired choir received twice as many flying buttresses, shortening the distance between its load paths. Up went new centering, back went ribs and webbing. No stronger material had arrived. The geometry simply became denser and more cautious. Nothing works alone. Vault into ribs, ribs into piers, outward thrust into buttresses. One linked path carries every force to the ground. Every block first left a quarry, then traveled by cart or boat. Masons shaped, laborers hauled, carpenters framed, glaziers closed openings. One cathedral shared engineering across generations. At Beauvais, the repaired choir still rises about 48 meters above the floor. Its stone ceiling survives because every force is handed, piece by piece, to the earth. Next time, a wooden shuttle passes through Mughal hands for generations, until fire makes one weaver run back for the smallest tool in the workshop. A new story every week. Follow the golden thread, from before buttons to threads of time.